Okay, we're going to take notes on limits at infinity. These may be printed off in my room, but if not, the title of them is Limits at Infinity. And I'm not quite sure if I ran these copies off, but regardless, you can just copy what I'm writing down. Okay? Let's talk about the end behavior of a function on an infinite interval. Okay? Let's talk about this graph. Okay? We're looking at infinity. We're looking at positive infinity, negative infinity, and seeing what the limit is. Okay, so as the limit of, let's call this f of x, that's going to be the name of our function, as x approaches positive infinity. Well, as x approaches positive infinity, your limit is positive infinity. So you're basically looking at the limit and determining if it stops, if at some point it approaches a number and doesn't go past it, or if it continues to go in a direction, say positive or negative infinity. Okay, for the next one, let's say you have a line like this, and you wanted to know the limit of f of x as x approaches negative infinity. Well, as x is approaching negative infinity, your limit is going toward negative infinity. Okay, let's look at a graph. Say our graph looks like this. We have one that's going like that, and then the other side is going like that. We want to know the limit of f of x as x approaches positive infinity. Well, as x is approaching positive infinity, that's where positive infinity goes. What is y approaching? Well, y is, never gets past 0. Look at the y-axis. It never gets past 0, so your limit is 0. Okay? And then one more scenario. Let's say that you have a graph, and let's say 1, 2. Let's say your graph does this. I may have made that a little bit too high up. Okay? And say we want to know the limit as x approaches negative infinity, the limit of f of x, our function. Well, if you look, as x approaches negative infinity, and I made this a little high, but let's assume that it never touches 2. It's approaching 2, so the limit would be 2. Those are a couple of scenarios that we need to think about. Also, a horizontal asymptote. We need to know what that is. Okay, a horizontal asymptote. Sorry. So what that is the height that a function tries to but can't reach. Okay, as the x values get infinitely large or small. So for example, the one we were just looking at, it went like this and like this. So basically, there is a horizontal asymptote right here. Okay, and let's just say it's approaching 0. That would be our horizontal asymptote. As x is getting larger, as that value is getting larger. The limit is approaching the y value of 0. As x is getting smaller, it's approaching the same horizontal asymptote of 0. Okay? Those are just some things we want to think about. But there are always, in calculus, there's lots of rules. So when we're talking about x approaching positive infinity or negative infinity, we have some rules to help us keep everything straight. Okay? So the first rule is, if the degree of the numerator is less than the degree of the denominator, then the limit is 0. Okay? So if the degree in the numerator is smaller, so let's say x to the third plus 5 over x to the fourth minus 2. Okay? If the bottom is bigger, we call that bottom heavy. And the way I remember the limit on this is bottom heavy has 2 zeros in it, basically, 2 O's, double zeros. So the limit as x approaches positive or negative infinity of f of x is 0. So that's the first rule. If it's bottom heavy, the limit as the x approaches positive or negative infinity, the limit's 0. Okay? The next rule, let's change our color here. The next rule is if the denominator, the degree of the denominator and the numerator are the same. Okay? So if they're equal, if the coefficients in front of the highest power are the same, okay, sorry, I got distracted. If you have 2x cubed over 3x cubed, and let's just say minus 2x, and this is plus 4, okay, and if we want to find the limit as x approaches positive or negative infinity of our function, okay, if the powers, the highest degree, if they have the same highest degree, your limit will equal the coefficients in front. So your limit here would be 2/3. Okay? So if the powers are equal, then the limit is the ratio of the coefficients of the highest degree. Alright? And then the last one. So we said bottom heavy, 0. Equal coefficients, then you just take the equal degrees, you're going to take the front, okay, what's in front of them, and that is your answer. Alright, the last rule you have is, well, let's just think about it. We had bottom heavy, we had equal, so now it's time to do top heavy. So if you have 3x cubed over 2x squared minus 1, okay, well this one is obviously the numerator's degree is higher, so we call this top heavy, okay. If it's top heavy, then the limit of f of x as x approaches positive or negative infinity is positive or negative infinity. That's your answer. If it's top heavy, it's infinity. If it's bottom heavy, the limit's 0. If they're equal, it's the coefficients in front of those, the highest degrees. Those are your 3 rules. That's all you have to know to do limits at infinity. So let's work a few together. Just to me, this is pretty easy. You just learn the rules. Now you could graph it and look at it and see But it's going to be hard to see if the limit's a fraction. But let's do the limit as x approaches infinity of 3x squared minus 2 over 5x squared plus x plus 4. Okay, so let's think about this. Is it bottom heavy, top heavy, or equal powers? Well, it's equal powers. Okay, so you might want to just write that down so you know what rule it is. It's equal powers rule. So y, or your limit, equals 3/5. And that's it. Pretty easy. Those are really easy. If you know the rule, you got it. Okay, let's look at the next one. Let's look at B. The limit as x approaches negative infinity of 3x squared minus 2 over 5x to the 4th plus x plus 4. Okay, so this one is bottom heavy. So write your rule down. Bottom heavy. And we know that if it's bottom heavy, the limit is 0. And that's it. Not a lot of calculations on this. Pretty straightforward. Okay, let's look at the next one. Sorry. I'm trying to keep the colors different. Not that y'all probably don't care, but I guess that's just me. Alright, the limit as x approaches positive infinity. 3x cubed minus 2 over 5x squared plus x plus 4. Well, if you look at this one, you can tell that it is top heavy. Okay? It's top heavy, so if it's top heavy, as x approaches positive infinity, your answer is going to be positive infinity. Your limit will be positive infinity. Okay? Alright, I'm going to stop there. I'm going to work D, E, and F in a separate video because the maximum amount of time in each video is 15 minutes and I don't want to get cut off. So I'm going to stop here and resume in another video.